Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about OSIRIS-REx sample opening. So let's dive deep into it. So you have to understand, sometimes NASA plays the long-term game, so we should understand some context of what kind of time frame we are talking about here. So launch happened from Cape Canaveral on 8 September 2060. It's long ago. Arrival at Bennu happened at 3 December 2018. Then sample collection happened on 20 October 2020. I'm like, wait a minute, you arrived there, then sample collection so far? Well, because it was an uncharted territory, and again, telescopes cannot give you high resolution map of those puppies. We barely had like 5 or 6 pixels. That's all we had. So when it went there, it actually spent enough time orbiting, studying every single nook and carry. Only then it was like, okay, where is the right place where we can do the sample collection? So it took time. It took its sweet time. And because there was only one chance, they had to do it safely, cautiously. So sample collection happened on 20 October 2020, this puppy. Basically, they decided a flat spot was selected and then they just went wabaya and collected the material out of it. Then return to Earth happened on 10 May 2021 and sample return happened, basically return to Earth, as in like send back towards Earth. Sample return to us, basically home delivery, happened on 24 September 2023, this puppy basically. And next stop, yes, while the capsule has written and the mission is technically concluded, technically successful, they have decided to extend the mission, and now it will go to Apophis in April 2029. Yes, NASA does play some long game, like very long game. So this is just the historical context of this. So what about the sample? Now sample, it overperformed flat out. The aim was like everybody would be partying and orgasming if they would have collected 60 grams of material. That was the target. However, when they actually went wabam on it, it overflowed and they were scared. Like you can literally see that in live stream when this sort of images started to happen. It's like, oh, the problem was like at that time they thought like they may have collected stuff, but because it's leaking and the seals are not working as they're supposed to, they may be losing enough material, and maybe by the time we get it to Earth, we may be like, okay, 1 gram or something like that. So there was a very serious probability of failure. However, instead of testing the weight, because it was leaking, they just decided to just wabam it, basically just put it into a system and seal it because it was leaking. Ideally, they would have put it in robot arms full extension and moved it around, because NASA already has the detail what OSIRIS will do. If it is arms is out and moving it, it knows how much energy each joint will consume. So if you change the mass, the energy consumption changes and you can detect it, and you have gyroscopes there that will also compensate for it. So it will give you a very good approximation of the weight, not perfectly precise, but good enough where if you say it's like 1 kilo, it's 1 kilo. If you say 500 grams, it's 500 grams, that sort of thing. So they bypassed that stage. However, they had some hopeful estimate where they were like, we think we got it. And once they actually opened it and actually doing the final precise Earth gravity measurement, 250 grams of asteroid stuff. That is significantly more than their best prediction. That's like overflowing. And yes, it is overflowing. Fundamentally, like it just worked amazingly well, the sample. Now again, they needed it to acclimate to nitrogen environment. The glove box that you see is custom built for this puppy, and it only has nitrogen in there. Why nitrogen? Nitrogen is very inert. Now you were like, wait a minute, wouldn't it be better to put helium? It's even more inert. Well, yes and no. Yes, it's inert. Consequences, that puppy penetrates. Meaning, if you have a crystal, basically rock and stuff, it will penetrate too deep inside. Meaning, it can literally give you illusion of some different compound, even though it was your helium that contaminated it. So nitrogen was chosen, and they needed time to equilibrate. So that's why it opened on 11 October. So sample was like GG. So did we figure out something from the sample? Absolutely. And yes, you can see that they have, when I'm making this video, they have not actually opened the main canister yet. So much material is just spilling out of it. Now, you may be like, okay, why the heck is spilling out? It's a very static. Why the heck is spilling out? Remember, they were pushing nitrogen in the capsule itself to make sure the contamination does not go in. Yeah. So the moment they opened it, happened, so everything fell apart. And yes, every sampling that you are seeing right now is literally done from the dust that basically fall apart. So what is the early verdict? Early verdict is there is a lot of water in the system. In what format? Of course, not ice, not as in like just liquid. So what is the format here? Format is hydrated clay minerals. Basically, you see this sort of thing at river beds and things of that nature. So water is detected, and it also helps the water mystery of Earth, because for Earth case, like we have water. Now here's the deal: almost all planets have water. They can retain the water, yes or no. That's a different thing. But most of the planet always started with water. But question becomes, where did that water came from? So in case of Earth, there is two sources. First is volcanoes. You're like, wait a minute, volcanoes give out water? Yes, surprisingly large amount of steam comes out of volcanoes. Each basic volcano can give you like a few lakes worth of water. And imagine having like a volcanoes period where hundreds of them are happening. You can get enough water to have like basically oceans worth of it. Consequence is that we did study ocean water, we did study volcano water, and outcome was there is signature difference. So what is the second source? Second source is asteroids. Asteroids had enough water content in them, and yes, there is icy asteroids also, but other things can also deposit GG amounts of water. This helps in that theorem. Right now it's not precise. We know both of them helped, we just do not know what ratio. And of course, I do not think that it could ever be solved with precision, high enough precision, because it will be like, unless you have time machine, how would you know the percentage? So, and be mindful, cosmic rays keep changing the chemical properties, so let's see. But it helps to facilitate one of the missing vectors. And it has a lot of organic compound. What does organic mean here? Carbon. We are carbon based, so anytime we see carbon, we say organic. Now 5% by weight. Now, do we have other samples to compare to? Absolutely. We have moon samples, we have Japanese mission samples, we have a lot of other samples also. And not to mention, every time asteroid does come to Earth, many times they do become meteorite and do fall to the Earth, and we have collected it, we have studied it. So reality is that 5% by weight is classified as very rich. It's not super easy. You just do not go to like, oh, asteroid, it will have 5% carbon. That's not how it works. So 5% by weight is significant. And be mindful, this asteroid is supposed to be made into the early solar system. So whatever we are seeing is the early picture of what a solar system was. And how about the particles? Well, particles are in the fine dust categories and intermediate size particles. Fine dust, almost like sand. Intermediate, like take a rice grain, slice it in half, that's the size. So this is the basic analysis. This is the nitrogen chamber, and they have just like started to, and you can see that like they are very cautious. Like every gram, every milligram would be measured and calculated for. They're not going to be sloppy around it. They're going to be like damn sure. So what tools have we used? Well, at the time of making this video, they have used basic tool. Now be mindful, this process is taking much longer than anticipated, and everybody is happy about it now. Like, why delay and why happy? Well, delay is simply because they have so much material. They cannot just like, oops, who cares about this? We only want 60 gram. No. If you have even 1 gram extra, you're going to catalog it. You're going to study it, the damn thing. So they are just cleaning the stuff up. That's why the main canister has not been open. By the time you are watching the video, hopefully it could have been opened, but be mindful, we are in very early stage. So collecting all of that sample is physically taking time, and everybody's happy about it. It's like, hey, we're gonna have more samples, so we good. Everybody good with that. And or whatever sample was taken out of the system was studied with basically 4 or 5 things, like electron scanning microscope, optical microscope, ultraviolet microscope. You have X-ray computed tomography, CT scan, so to say, and that gave you this basically crystal analysis and all that, mineralography, so to say, very precise. And after cataloging, basically once we have figured out exactly how many grams, and I mean grams will be for us, for them it could be even nanograms, and I'm not joking, they are damn precise about this sort of stuff. Basically they're gonna be like milligram, under a milligram, because there are many ways of studying these things which are destructive. What does that mean? That simply means if you take a stuff, put it under a microscope slide, you're not going to do too much damage to it. Yes, you will have some light going to it and causing some changes to it, but it won't be destructive. But some scenarios require you to dissolve the stuff in some acid, some other, that's destructive. The moment you do destructive testing, the sample equals gone. So for that reason, they have to be very thorough about cataloging, and they are happy about it simply because some of the systems do require a bit more oomph. Basically, the material size has to be big enough. In those scenarios, because they have over collected, I'm pretty sure they have to revise the chart, how the heck they're gonna distribute it again. But so once they have done the cataloging, only then the samples will be distributed. What does distribution means here? Well, some sample will go to Japan, some will go to Canada, and majority will remain in USA, and majority of that itself will remain in archiving. They will not use all of it. We are already seeing like iron oxide, we are seeing water-based silica fibers. That's like almost like a brick. If you look a brick under a microscope, you will see something similar to this. And sulfide is there, iron oxide is there. So a lot of stuff. lot of stuff. This sort of things we're going to keep happening, and there's supposed to be around 250 scientists that are working around the clock just to study these things. So do expect some very in-depth research paper coming out of it. And because of the plethora of sample they got, like they were expecting 60 grams, they're like, bro, we good. We can have some really detailed analysis in the upcoming weeks, and actually it's going to take years. The project's supposed to be 2 years, so let's see. Now that's on the ground. What is happening to that puppy? Well, Osiris has been renamed. This puppy is now Osiris Apex. Apex simply stands for Apophis Explorer. Why? Well, it's a near Earth asteroid, so that means the orbit intersects with Earth's orbit, so it's very close by. And there is a problem with this puppy is that it's potentially hazardous object. What does that translate to? That translates to that there are events in the cosmic world that if that event just happens very poorly for us, like just right, it's gonna go wabam to Earth. So for that reason, we classified them as potentially hazardous object. We are very precise with our radio telescopy and all that jazz. We are very precise when we are measuring something, but only to a certain degree. One orbit we can be precise, two orbit we can be precise. If you're like, what about 500th orbit from now? We are lol at that point. So our precision becomes dilute as time keeps going forward. That is why you will always hear this potentially hazardous object. You will never be like, no, this will hit, this will not hit. That can only happen to something that is very close to us temporarily speaking. In time they are like, okay, one orbit for us, okay, then we can be damn sure it's gonna hit or not hit. 10 orbits from now, we do not know, things change. Like for example, there's subtle thing that sun hits things up. It's like, okay, but here's the sun is not a constant entity. Yes, it has almost more or less the same flux output, but flux output changes. It hits the stuff. If it's spinning, the other side gets a lot of infrared photons dumped into the vacuum, and consequences there is a thrust, little bit of thrust. Now how little? Very little. Now does it have effect? Not on orbit 1 but orbit 500 it has an effect. So that's why this potentially hazardous objects are very scary to us, even though we can be damn sure that if we're going to detect it, and nowadays after the DART mission we can actually do something about it. It's still one of those things that is like more data is needed. So it's gonna go there. Now it's supposed to cross very close to Earth on 13 April 2029. Now how the heck this is going to do that? It no longer has the canister. So what the hell is going to do? Well, it's going to do Tokyo drifting. So it's going to go as close to the surface and fire as much thrust power as it can, and hopefully it's going to evacuate enough material. Now is it needed? Yes and no. It has a lot of instrument. It's going to study the damn thing throughout without any issue. But after it has done all the step 1 mapping and studied everything, then it's going to do this thruster digging trip. Why? Osiris have taught us that these things are very loosely bound. So hopefully, assuming this structure also plays the same ecosystem, if you fire thrusters so close to the surface, it will dig. Now benefit of digging is that now you get subsurface access. So all the spectrograph and all the cameras, all the instrument on the spacecraft itself can now study a fresh, uncooked side of this asteroid. That will provide a bit more context. So that's a desirable thing, but that's supposed to happen in 2029. So it's a long game. And you should look into the orbit of Osiris Apex. The orbit is like, what the hell? But it's supposed to be like that. So this was my presentation on OSIRIS-REx sample opening. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.